Good morning, everybody. Welcome to this new webinar, the first one we have on 2026. My name is Harry. I'm very happy to share a new webinar with you guys. This time is the term for ultrasonic atomization, and I am very happy to start this presentation where we are going to show the laboratory size atomizer. I have the pleasure of sharing this webinar with my colleagues from 3D Lab, the creators of this technology. And well, let's start. So first, let me quickly introduce our company. So as some of you already know, some of you have already joined other webinars hosted by Additive Plus. Well, Additive Plus is a additive manufacturing company based in the USA. We have our offices in California, and we're specialized in all the spectrum for industrial 3D printing and also for atomization. So along these last years, we have been dedicated to not only production projects, but also we have dedicated our efforts to R&D in a way that we have collaborated with many universities. Also, we have worked together with other laboratories, including national laboratories, where our expertise has been very valuable for them. So our vision has always been to accelerate the development and the transition to new technologies and the manufacturing that is changing the way how we produce parts, and also opening the doors to the next generation manufacturing. Some of our partners in this field of technologies are in the spectrum of metals, also ceramics, as well as polymers. And also we are dedicated to 3D scanning, also to metal atomization, as I just mentioned, and several technologies that are complementary, for example, to metal powder metal powder analysis for quality purposes, and of course also equipment for post-process of 3D printing. So this said, I have the pleasure to introduce you to my colleague Marius. He is from 3D Lab, the manufacturer, and they are the inventors of the ultrasonic atomization technology. So please, you can continue from here.
Hello, everybody. Welcome.
Okay. Yes, let's go. We are good. We're good.
Thank you. As I mentioned, I would like to thank you, Additive Plus and Harry, for the introduction. During today's webinar, we would like to show you the capabilities behind our ultrasonic atomization technology. And the main topic, as already Harry showed you, is the future of metal powder production. Compact ultrasonic atomization for smart custom manufacturing. And to be honest, this topic reflects perfectly what we have done in the previous months. I saw the message. Okay, right now you can hear me. Great. This topic perfectly reflects what we have done in the previous months. I mean, we introduced completely new line of atomizers, but let's go through it step by step, because first I would like to share briefly the information about our company, which is located in Warsaw, the capital of Poland. And you should know that whole R&D department and production facility is located in this one building. It means we are largely self-sufficient in terms of the development and production. On this picture, you can see a part of our production, our R&D department, and few members of our crew. But it is also an excellent place to invite our guests whenever they need to check the capabilities of our technology live and run the atomization trials whenever they need to check their own materials. But it is also to mention the background behind our achievements. I believe for all today's participants, it's quite important to understand why we developed a new atomization technology. First and foremost, you should know that the 3D Lab company was founded in 2007. Then 1 year later, we signed a company agreement with 3D Systems. I believe everybody knows 3D Systems perfectly. Few years later, we signed a similar agreement with a Coherent, nowadays a 2-1 Lab company, and they are also a manufacturer of small 3D metal printer. And to be honest, that was a very crucial time for us, because those customers who purchased from us the 3 metal printers, whether the bigger or smaller one, they started asking us for non-standard alloys, small batches. That was completely not profitable for them to order small batches from classic huge gas atomizers. That's why we founded a niche for our company. It results with the agreement with the investors in 2018, and thanks to this situation, we've launched the first device in 2019. Currently, we are working under, I can say, 2 names: 3D Lab, which is responsible for the manufacturing and development process, and Arcway, which is the main, I would say, organization responsible for the global sales. And I am in the role of the sales director in Arcway company. I can say nowadays we've sold more than 100 different machines and atomizers worldwide. To be honest, bottlenecks in metal additive manufacturing industries helped us to achieve this success. Those bottlenecks are mainly related with limited list of materials behind classic gas atomizers, very slow material change process. Today, I will also mention a few things about the material change process in case of our technology. In case of classic gas atomizer, we need to take into account a huge price, of course, behind those solutions, and very big facility to install, to run the device. I can say during creation, our technology, we were guided by the idea to create laboratory size equipment to avoid big open fire construction, to speed up new materials development, and we achieve those 3 major goals. Our solution is as well very affordable solution, for sure, incomparable with classic gas atomizers. Our approach resulted with, as I already told you, installation in many different countries all over the world, and most of our customers are from very well-known or famous organizations, famous universities, R&D centers, research centers in big companies. But let's say something more about solution which can optimize atomization efficiency. As I already told you, this year is particularly important for us because nowadays we can speak about the latest innovations. We are just in the middle of the transition from the 3rd generation to the newest one, 4th generation of our atomizers. We already stopped a production of the previous generation, and we announced the premiere of the newest version during the Formrex trade show. I can say, and I believe we can start discussing about the capabilities behind the atomizer features from showing you this short video. I believe not everyone can hear the lecture, so I will try to explain what we can see right now. Right now we can see the automatic torch movement and the wire feeding system. Right now you can see the atomized powder, which we can move through the process chamber directly to the cyclone, and then all particles lower than 5 or 10 microns are going to the long life filtering system. And it's very important feature because none of our customers change the filtration system, which I will explain a little bit later. This filtration system was designed with the German company, Herding company, and as I mentioned, this is quite important feature because you don't need to spend additional money for the filtration system. On this additional screen, which is located in the front of the operator eyes, which is also something new in the newest generation, we can control all process, all data, and we can speed up the atomization process in comparison, for example, to the previous generation of our atomizers. Let's tell more about the possibilities behind the new machines. And I would like to start from the new 8 Lab. This machine was completely redesigned in terms of the software and hardware. We've added ultrasonic and multi-frequency generator, which is helping us to achieve even bit better results in terms of the particle size distribution. In that case, the customer can switch from thick or plasma whenever they need to, for example, implement additional module in the form of plasma heating source. In that case, we also change a little bit body, and inside of the machine, we have right now a coating system which help us to improve the filtration system. As I've told you during the short video, in our case, the customers don't need to change the filtration systems at all. During the atomization process, the operator can see on the control panel what is the level of the contamination. And this is the crucial information for the customer because we are not using standard HEPA filters. This is HESL filtration system, which is much better comparing to the HEPA filtration system. In that case, you will see the percentage level on your control panel, and you will know when you need to clean the filtration system. By cleaning the filtration system, I mean 2 processes and 2 clicks of the button. In that case, we need to simply release the argon pressure onto filtration system, and then we can blow off all contamination from the filtration system into the waste container. Then filtration system is ready, for example, to work with another material. But to be honest, the real magic we can describe behind completely new line of our atomizers. This is new Atos Spark. In that case, we are keeping all functionalities like in the Atos Lab, but in that case, the customer can receive much more features. First of all, we are adding additional screen. As I told you, in the front of your eyes, right now we have 18.5-inch screen, which can show you much more data, like much more graphs, the humidity graphs, the temperature graphs. We can also observe the view from not 1, but 2 cameras. Those cameras are much more faster and equipped with AI options. In that case, the real magic is behind those cameras, because in that case, we can recognize what is happening in the process chamber. I mean, for example, whenever the customer is working with very automatic process, like with the wire, the camera can recognize any failures during the process, and the process and the software can speed up the process, or it can slow down the process, or maybe the process should be completely stopped, maybe because of the wrong parameters. Moreover, worth to mention that Atos Spark is already equipped with 2 heat sources. I mean here the thick or plasma. Sometimes we have very interesting discussions with our guests, with our customers, or during some conferences, because some of people asking us for the proper heat source. There is no such a thing like one proper heat source for every material. Some of the material has lower melting points, and TIG option will be perfect for lower melting points. But at the same time, whenever you are struggling with the materials, refractory materials, with the temperature melting point, for example, above 2800 degree, the plasma option can be more suitable option for you. In that case, also, we change the software. Atos Spark is giving you a possibility to check the periodic table, choose the elements of the material you would like to work with the percentage levels, and the system will tell you and will guide you what parameters you should work with. Like, for example, it will show you the proper melting point. It will guide you through the proper current, which you should set up for the proper atomization process. As you can see here, in terms of the comparison between the new AtoLab and Atos Spark, the customer can receive much more option and features. Let's talk about the input materials and the feedstock. This is very important topic for our customers and for our technology, because many times we receiving some requests and questions about the possibilities to work with different input materials. You should know that all our machines are equipped with the wire feeding systems. And to be honest, this is one of the easiest options to work with the atomizer. Because please imagine the situation when you can put a big spool of the wire to the system with a diameter from 0.8 to 2.2 millimeter, and the process can be almost fully automatic. To present you a proof of this atomization process from the wire, I would like to switch to another window and show you, of course, with the previous generation, the atomization process, which is fully automatic from nitinol. In that case, we've atomized the nitinol wire. As I remember correctly, that was 1.5 millimeter diameter. But what is the most important for you right now is the view from the chamber. In that case, the process is fully automatic. Moreover, we've implemented automatic torch movement, which can be programmed. Then the operator can go to another room and he can even control the process from the remote control panel. To show you how to do this, I will show you another short video. As I explained, we can deliver an industry-grade tablet which allows you to work with the machine from the completely different place. And what is the most important for our customers, we can even control, let's switch to the presentation, we can even control the installed atomizers all over the world. Of course, we need to have a permission from our customers to connect with the device, but please imagine the situation that you don't need to wait for the technician to resolve some problems. In many cases, we can connect with the device and we can even run the atomization process. The only thing you need to do is to put the input material to the process chamber, and our application engineer or the technical crew can do the rest. Let's continue the describing of the feeding systems. On the screen right now, you can see few options. The single rod feeding system is the best option for R&D department, because not only the wire is the option you would like to work with in the future. Let's imagine the situation that you would like to work with pre-alloyed material. Maybe you already have a casting unit. In that case, you can cast your own material and work with the rods. You can even work with the bend rods. The single rod feeding system is giving you an option to work with the rods up to 110 millimeter length and up to 10 millimeter diameter. You can even rotate a rod. But I would like to underline that all our developments are being made after the discussions with our customers. We are using their experiences. That's why we developed additional modules for the ATO lab. Revolver rod feeding system and multi-rod feeding system are giving you an option to work with multiple rods, not only one rods, but for example, up to 10 rods with a maximum length up to, for example, 120 millimeters each, or even one long rod up to 1 meter 20 centimeters. And what is very important, we had a lot of discussion about different shape input material. That's why we are giving you an option to work with even strange shape of the input material by special grabbing system. In that case, we can also atomize very strange shaped materials. Right now on this screen, on this slide, you can see a comparison between the wire atomization process on the left and the rod atomization process on the right. As I already told you, due to the fact that the wire can be mounted on a big spool, in that case, the process can be fully automatic. What is also very important for our technology is the possibility to work with multiple different particle size distribution. In 2019, once we started with our technology, once we delivered the first machine, it was only one option. I will switch to another screen. Give me a second. I hope you can see the screen. This is the view from our website, because right now I would like to tell you a little bit more about the PSD options. All our machines are equipped with different ultrasonic modules. And all our machines are starting with 35 kilohertz option. The general rule is as follows. The higher the frequency, the smaller particle size distribution. The lower the frequency, the bigger particle size distribution. It means with multiple different frequency modules, we can cover multiple different scenarios, and we can also deliver powders to many different technologies, not only LPBF technology, like 35 kilohertz or 52 kilohertz. We also announced 1 year ago ultra high frequency system, which will be also compatible with the binder jetting, because in that case, we can create most of the powder between 15 to 25 microns. As you can see, the particle size distribution is very narrow. This is also something incomparable with classic gas atomizers. But whenever you would like to work with DED technology, EBM technology, you can switch to the smaller, lower frequency system, which allows you to work with smaller particles. This is the picture of, this is an example of already atomized group of the materials, like the aluminum-based alloys, copper-based alloys, nickel-based alloys. We already tested more than 400 different materials, and a possibility to switch between different feedstock are giving us the option to test more and more new alloys. Right now, I'm showing you quite interesting time lapse, which is, of course, speed up for the webinar purposes, but it's showing you that this atomization process can be almost fully automatic without almost any need of the operator control. It is quite interesting that you can see right now the view of the control panel, which the same view of the control panel can be turned on the computer or on the tablet with the completely different location. But right now, let's focus about another possibilities. I already introduced you several different input materials, like the wire feeding option, rod feeding option, and a possibility to work with custom shape feedstock. But what about the situation when you would like to work with scraps or maybe a powder. Sometimes we are receiving requests how to turn powder into a powder. Maybe those customers would like to work with much better quality powder. That's why they are asking us about this possibility. 3 years ago, we've changed the game because the induction melting system, which is a module for the basic machine, for the basic ATO lab or ATO Spark, is giving you an option to work with both crucible and rod feeding system, which you can atomize directly in the electric field. In that case, induction melting system works up to 1500 degrees in terms of the melting point for the materials you would like to work with. I think on this graph, you can perfectly see the comparison between the crucible and rod feeding option. By the nature of the process, if you are using the induction melting system, you are melting pure material because the oxides layer and all impurities will always stay in the top of the crucible. So you are melting only the pure material. We also compared the efficiency between the standard version and the induction melting system. And we found out the efficiency is up to 2 to 4 times better comparing to the basic solution. To explain you how we can work with the induction melting system, I would like you to show this 18 karat gold by using our induction melting system. Right now, you can see the view from the control panel with the most important data like the temperature, the target temperature, the argon flow, and we can also observe the process from the camera view. Whole crucibles are equipped with the thermocouples, so we can check the temperature inside of the crucible. And once the material is fully melted inside of the crucible, by one push of the button, we can release the material on the atomization platform. As I already told you, whenever you need to work with lower melting points elements, when you need to keep the proper chemical composition, always induction melting system seems to be perfect choice. I believe right now it's the perfect moment to hand over to Harry, which can add few additional points about powder printing and powder analysis.
Great, thank you very much, Marius. So my screen again, so 1 second.
Harry, I believe you can start your section.
So, all right. So I would like to complement the presentation from Marius with our field and how we complement the fast research and fast development of metal powders using an appropriate additive manufacturing solution. So this is how we do. At Additive Plus, we are also manufacturers of our online of 3D printers for metals. These technologies laser powder bed fusion based, and its main focus is to accelerate the maximum the benchmarking or the prototyping with metals, but especially with those metals which have been custom made or that have been produced for let's say new developments or like very scarce materials. So this is a quick example of how our 3D printers combine with the laboratory atomization. The first one I would like to show you is our smallest solution. This is a desktop size laser powder bed fusion 3D printer. I made a very visual comparison here where you can see 3 spoons of metal powder. This is somehow to represent that you will need like some tablespoons only to fill the entire vat of the 3D printer, and you will be able to start making your micro benchmarks, or also making small parts. Also, I have added here in this graph the cam sizer. The cam sizer is one of our devices which is dedicated for analysis of the shape and the size of particles. And this is especially interesting because you will be able, using the cam sizer, to obtain results about shape and dimensions very quickly, in just a matter of seconds. So this will prevent of like spending like several hours that would normally take to use, for example, electron scanning for small samples of powder. Same story with, for example, our machine, the AO Metal A50, where you can fill the entire vat with just a teacup of metal powder. This is especially relevant, and this device was super interesting because this was born as an idea to complement the atomization the atomization laboratory for a national lab in the USA, where they were handling a super high value metal powder, and they wanted a device that was powerful enough to handle that powder, but that can also handle very small quantities of the powder. So this printer is special for that. I would greatly recommend this for scarce material and also precious metals. The size of this device is 1.9 inches for the build platform diameter, and for the height, you can work up to 3.9 inches. And the larger equipment from this line is the AO Metal A100. For this one, you will be using almost like less than what a bottle of wine can fit of metal powder. So you will be able to work also with a highly valuable custom scarce material. But at the same time, you will be able to make larger parts because you're able to work in a build cylinder of almost 4 inches of diameter and 4 inches of height. So for the larger systems, we also have some very interesting additional features which can enhance the experience for research and development on more difficult materials, let's say. So for example, one of the additional features that we can include in our machines is, for instance, the high temperature build platform. You're able to reach up to 900 degrees Celsius of a build platform temperature, and this will allow the user to be able to work with refractory alloys such as niobium, molybdenum, tantalum, and also tungsten. Also, to make the spectrum of materials broader, we also can include a dual laser configuration, which means that you can have a laser of up to 1 kilowatt, 1000 watts infrared laser, and complement your configuration with a blue laser of 455 micron nanometer. I'm sorry, I confused here the dimensions. So it's a 455 nanometer wavelength, and this will allow to easily work with precious metals such as gold, platinum, and also challenging materials such as copper and very reflective and precious metals. So this said, I would like to show you how the workflow for faster ND works and how is our vision for this. In this workflow, um, we consider a metal feedstock. This could be of any shape, as Marius have already shared. We can work with, for example, rods, wire, and we can also prepare the feedstock using a casting furnace. We can, after this, atomize the powder, sieve the powder to prepare it. Then we can do quality assurance of this powder. And after this, the powder is ready for starting to 3D print. If the material is super valuable, we would like sometimes to reuse this material, or we would like to be able to reuse the scraps or the support generated during the 3D printing. So this cycle repeats, and we have a closed workflow for the development of this additive process and the production of a novel material metal powder. So, all right, this is what I wanted to share, like very briefly, since this presentation is not focusing 3D printing. So I give the word again to my colleague Marius to continue with this explanation about metal atomization.
Thank you, Harry. Thank you. Thank you for your part. I will share my screen again.
All right.
Give me a second. Okay, I hope you can see my screen right now. As Harry showed you similar workflow, I would like to sum up one more time the knowledge I already shared with you, with our participants. I already explained multiple different scenarios, multiple different input materials, and a scenario when we can work with different shape, irregular shape of the input material, which we can atomize, for example, in the induction melting system. Then we can sieve the material, for example, with our ultrasonic sieving system, which is fully compatible with the devices. Then you can use the cam sizer for the measurements, as already Harry explained you, and use the already tested powder with the another processes, like for example 3D printing process, and you can repeat the cycle. Whenever you need to work with standard shape input materials like wires or the scraps, this scenario is like you can see right now. But let's imagine the situation when you would like to work with scraps, but at the same time, the temperature melting point of your input materials exceeding the possibilities of the induction melting system, which is, to remind you, for the induction melting system, 1500 degrees. In that case, we have another solution. This is AutoCast, induction casting furnace, which is completely self-sufficient casting unit with the melting point up to 3000 degrees. In that case, this unit is equipped with the vacuum pump, with the chiller, with all necessary equipment, which allows you to prepare the feedstock from the irregular shape input materials, even up to 3000 degrees. With that solution, you can prepare perfectly fitted feedstock for the rod feeding system, for example. And you can work with failure printouts, you can work with scraps, you can cut some parts. Whenever you would like to fit something to the crucible with two sizes, 75 cubic centimeters or 150, you can put those parts into the crucible, and by simple tilting of the melted material, you can prepare your own feedstock. In that case, you will achieve, I would say, this cycle. With the AutoCast, you will prepare the input material. Then, without a necessity to work with the induction melting system module, you will simply atomize the rods, which are created with the AutoCast, with the basic AutoLab or AutoSpark. And then the process is the same: sieving, analyzing, printing, or different processes like powder spraying. I am showing you this loop to give you the information that we have multiple different answers for multiple different scenarios. But let's say a few words about the quality of metal powders. Based on our experience, I can tell you that we already tested around 400 different materials with the melting points up to 3400 degrees. The only need from our side is to know the customer needs and the melting points of their alloys. Then we can choose the proper path to atomize their material. In the past, we found out that particle size distribution, sphericity, oxygen level, and the chemical composition are one of the most important factors for our customers. That's why we need to be sure that we can please even demand customers. Right now, I'm showing you a simple comparison between the classical gas atomizer powder on the left in comparison to the ultrasonic atomized powder on the right-hand side. Those are two different examples, Inconel 718 and Inconel 625. But to be honest, in terms of the sphericity or the flowability, you will achieve the same results for almost all powders. In that case, I'm showing you another few examples, like a copper, Highness 282, or even tantalum. I would like to remind you and underline that whenever you are working with the induction melting system, by the nature of the process, you will achieve, in most cases, such shiny powder as I'm showing you on the left corner. In that case, this is a copper example. More and more requests we are receiving from the customers who would like to test the application related to the niobium. Right now, you can see few SEM examination of the niobium powders and also a histogram graph with 3 different results in terms of the particle size distribution with the 35 kilohertz, 20 kilohertz, and 52 kilohertz examples. Niobium is particularly important for us nowadays because, as I mentioned, more and more customers asking us about that. In that case, we also achieved great results. And you can also see a short video which presenting the atomization process, the continuous atomization process of long niobium rod, as I remember correctly, almost 1 meter 20 centimeter. A copper is another example of perfectly fitted material for the induction melting system. Low melting point is perfect for induction melting system. In that case, we can also increase the efficiency of the atomization process and the through output in comparison to the, for example, classic rod atomization process in the basic module. And this is one of the most, for me, fascinating example. This is magnesium, WE43. This slide, this picture is particularly important for our company because this is a story behind the customer choice. Please imagine the situation that one of our customer bought a basic module few years ago, a standard module with an option to work with wire and rods. After some time, he started working with magnesium. This is, as you already know, highly reactive materials. But we are not creating a combustion atmosphere at all in our process chamber. Whole path from the atomization platform to the collecting container is under argon atmosphere. We also tested in external accredited laboratories, and we are sure that you can work with even highly reactive materials. In case of this customer, they started asking us about the possibility of creating magnesium powder with a standard option, I mean TIG. And this is a perfect example when TIG or even a plasma will be not suitable for low melting points materials. or at least it will be much harder to achieve a proper result without the evaporation. And in that case, the evaporation was the biggest problem with the customer operations. Once we developed the induction melting system, we asked the customer to check their material once again, but this time on the IMS module. And we achieved perfect matching in terms of the chemical composition. We kept the title of the material and we achieve a great results in terms of the customer needs. Those reports you can also download from our website. Once the powder was tested by the customer, the induction melting system was the obvious choice for them. We've done the same with gold. We found out that the precious materials are perfectly fitted for induction melting system. We already tried several types of gold, also platinum and silver. And we have also in our portfolio a dedicated version of our atomizer. It's called Atonoble. But because of the limited time of this webinar, we are not showing you and we are not focusing on the precious materials during this webinar. It's worth to mention also about the auxiliary equipment. The auxiliary equipment is also very important to the proper workflow, because what to do with the atomized powder, especially when you need to work with the reactive materials. That's why we've prepared our version of the ultrasonic sieving system, which is fully compatible with ATO atomizers. By this compatibility, I mean, for example, the powder container. Maybe you remember from the previous slide that I already mentioned that whole path from the atomization platform and the just to collecting container is under argon atmosphere. It means that after atomization process, you can close the valve and your powder will be safe under argon atmosphere. Then you can go with this powder to the sieving station, turn on the inert atmosphere, and you can sieve the powder even under inert atmosphere. This ATO sieve is also like a classificator, because inside of the chamber we are using not one but two meshes. It means that desired powder is going to the collecting container, but also you will find two different particle size distribution on the two different meshes, depends your needs. The proper cleaning process is crucial for the atomization process, because what to do whenever you would like to swap between non-reactive to reactive materials? I believe you need to avoid a cross-contamination. In our case, and thanks to the modular equipment inside of our atomizers, you can simply unmount the most important parts responsible for the powder transportation and put to the ultrasonic cleaner at once. It means within 1.5 hours, you can clean the system, then you can mount the parts again. Maybe this is another 15 minutes. And within 2 hours, your ATO will be fully prepared for completely new process without any toweling, without diving into the process chamber and cleaning by your own hands. You can achieve great cleanliness, almost fully automatic. Last unit I would like to describe during this webinar will be the unit which can be responsible for increasing the quality of the powder after atomization process or after many different iterations of 3D printing process. Because whenever you are familiar with the 3D printing process, you can reuse the same powder many times. But because of the adhesion processes, because of adding additional fumes, maybe you will see that the quality of the powder will be decreasing. For that reason, last year we developed a completely new unit which can help you to clean the powder and dry the powder after atomization process. Today we have presented the possibilities behind the ultrasonic technology. We also shown some examples of application. We introduced customers who place their trust on us. But I believe it's worth to mention that we are focusing not only on technological development, but also to protect our intellectual property through the patent law. We have a dedicated team which handle these matters, and the best example is the patent granted for the whole ultrasonic atomization process in United States. We hold similar patents in China, Korea, or Japan. We have multiple different smaller and bigger patents also in different countries. And of course, we still fighting to achieve more great results in different countries. I hope the materials, the presentation has been clear and easy to follow. I, at the same time, aware that it's quite hard to share all deep details during short webinar. That's why I would like to encourage you to contact with our partner Additive Plus, especially all those participants from the United States, to arrange one-on-one additional meeting to discuss more details behind our technology, because I'm sure they can also share with you much more information, much more technological information, success story, and they can help you to make the proper choice. Thank you for this presentation, and I believe we can start 15 minutes Q&A session.
All right, thank you very much, Mariusz. As always, very informative and complete presentation. So
thank you, Harry.
Thank you very much. So all the questions are welcome. Please feel free to write them in the chat, and one of our moderators are going to pass the questions to us.
Yes, so we have some questions coming. And
okay,
yeah, one of the participants is asking about inert gases that are used in the process and in what quantities. I believe it concerns the atomization process.
Okay, this is quite. Thank you for the question. This is quite important question. Our recommendation is to use argon gas as a shielding gas, and it should be argon gas 5.0. In terms of the consumption, it's between 15 to 20 liters per minute, and we are also using inside of our system a recirculation system. It means, thanks to the recirculation system, we can consume less argon gas.
Okay, and the second part of the question is there a vacuum to be maintained? So I guess it still concerns the process inside the atomization. So about the vacuum.
Thank you. We are using a vacuum pump to prepare the inert atmosphere much more quicker. Thanks to the vacuum pump, we can prepare the inert atmosphere within, I believe, 10 minutes. And during the atomization process, we can achieve the oxygen level below 10 ppm.
Okay. One question, what is the shelf life of materials atomized using this technology? Maria, can you please explain? Maybe our presenter knows, but shelf life of materials atomized using this technology.
It's quite complex questions.
I believe it's like storing the
Yes.
material after atomization. Okay. If I read you correctly, Maria, say yes. If not, please explain. But I believe
it's quite complex question, but it depends. Okay, it depends because there are different ways of storing the powders. In most cases, our customers are using the powder which is atomized on our units daily. Okay, so they are producing the powder and then they are not storing the powder too long. But whenever you are using a sealed container which we are adding to our atomizers, there is no oxygen inside of the container. That's why the shelf time can be long. I know that the long is a very general answer, but due to the fact that there is no oxygen inside of the container, the powder will be dry and without additional oxidation.
Okay. And what pressure of the chamber? What pressure we have in the chamber before argon introduction? So I believe quite precise and technical question for the user.
I'm not sure if I understood the question correctly. I believe it's around 200 millibars, but we can double check with our technician crew and we can answer this question by our partners.
Sure. So the next question is about, is there any minimal particle size and can a nanomaterial be produced, which means below 1 micron?
Very good question. During the presentation, I showed you multiple different options behind the particle size distribution. Nowadays, we can work with multiple multi-generator system, which allows you to easy swap between the frequencies. However, even with the highest possible option, it means 72 kilohertz, we cannot produce the particles below 1 microns.
Are there any new modules coming, and if the machine can be upgraded in the future?
Yes, we've just announced the few new modules during the Formex trade show last November. I mean, mainly the new 8 Lab, the new 8 Spark, completely new induction melting system. During today's presentation, I also showed you the 8 Pure, which is responsible to increase the quality of the powder. Of course, we are thinking about the new modules, but if I understood the question correctly, all our customers who purchased the machines in the past can order the upcoming new units and modules because all our machine can be retrofitted.
Okay, thank you. One question regarding change of the material. How we can keep the purity between atomizations?
Okay. I will answer with the historical background. Okay. I showed you the AtoClean. This is the ultrasonic cleaning system. This is, of course, not a rocket science. It's made by us, but in the previous years, we found out that the commercially available ultrasonic cleaners were not feasible for our technology, because we found out some impurities after the cleaning processes. We found out that there is still a cross-contamination. That's why we are quite knowledgeable about the ultrasonic technology. We decided to develop our own ultrasonic cleaning station. With our own ultrasonic cleaning station, which is big enough to fit all internal components like the process chamber, the cyclone, the collecting container at once, we can be sure that we can put those elements at once and we can achieve perfectly results in terms of the purity between processes, because this is our daily routine. All our customers since 2 years are receiving the ATO clean, and they are not claiming any troubles about the cleaning processes. Nowadays, we are sure that with this system, it's much more easier to maintain the cleanliness between the atomization processes. Okay, Harry, Mateusz, I believe we can end this webinar. I would like to sincerely thanks to all our participants, to you, Harry, to you, Mateusz, for the moderation. As I already told, I hope the material was easy to follow. And in case of any additional doubts or thoughts, please contact also with Additive Plus.
Great. Thank you very much, Marius, Mateus, for all your support. Yes, as Additive Plus, we will be very happy to have all your questions. You know that you can find us also in social media. We'll be hosting other webinars during this year. Our next webinar will be next month around technical ceramics. And I am always welcome to chat via LinkedIn, or also you can send me an email, and I am open for any of your questions. It could be about ultrasonic atomization or 3D printing. Always welcome.
Thank you very much. One more time.
Thank you.
Thank you. Bye-bye.